This is a road test of a Nordic Semiconductor nPM1300 evaluation kit and its accompanying nPM fuel gauge board. So I'm just going to unbox them here and see what's inside. So the nPM1300 is a power management integrated circuit, and this evaluation card allows us to test it with all kinds of different scenarios. One of them being with its own fuel gauge board. So let's see what's in here. So I think this is a load that allows us to run batteries with a constant current output. And this just plugs in. It's got a nice connector that's actually set up for this card. So now we have a full-blown system. There's a USB connector for the computer and a USB connector for power. There's a couple of little JST style connectors here for batteries. There's some buttons down here. And lots of connectors down here. Now, I wanted to do this road test for a specific reason. And that is because I have a pile of lithium polymer batteries, and they're anywhere from a couple of months old to about 12 years old. So this is a tray with some batteries on it. You can see this one, for example, is 850 milliamp hours. This one doesn't say, but I can look it up. And we have some bigger ones here, which are larger, but they only say 680 milliamp hours, 3.7 volts nominal. This is the same thing, but you can see I have a lot of them. And then there's another tray with some smaller batteries in there. These ones, 335 milliamp hours. Watt hours, 2000 milliamp hours. I don't believe that, but we will see. Oh, it's 2 watt hours. Sorry, that's just a bad calculation on my part. And this one's 550 milliamp hours. So quite a variety. And what I want to do is determine if these things, some of these older batteries have retained their capacity, and just to see how that's changed over time. And I also want to characterize these batteries to see how their discharge curve looks. And the software that Nordic Semiconductor provides to work with this, the NRF Connect for desktop, has all sorts of capabilities to do these tests automatically, so I don't really have to write any code probably to do what I want to do with these batteries. So that's going to be interesting, and we'll just see in this road test how we get along with that. So the first thing I want to do is sort of stabilize this connector, just so that when I'm playing around with it, I'm not stressing the connector and wiggling it. So what I did was I printed a little tray and I put some nice big rubber feet on it. Now this thing is a power sink, so it may get warm. It's got a heatsink on it, and if you look closely, you probably can't see it, but there's all sorts of vias that are looking like they're thermal vias to make sure that the heat gets from the top to the bottom and is evenly distributed. However, so what we're going to do, so I've left some holes in here for the air to circulate and get to the card, and also some slots at the sides for the air to get out. But if I just drop that in there, we can see that it fits, and there are a bunch of little screws that have to hold this thing together. So let's do that. My hands are getting in the way of the camera, but you'll be able to see some of these going in. Whoa! Flipped it right off the table. And the last one. Alright, so we now have a stable card situation, and the connectors are all accessible here. And there should be pretty good airflow around that hot end of the circuit. Nice and firmly in place. Okay, so we'll have to connect that up now and take a look at the NRF connector for desktop software package. Okay, I looked them up. I didn't get a part number, but these are JST connectors, and it might take me too long to get some in to make these connections here. But of course, these headers they're connected to the same connectors, so I may be able to use these headers instead of these little JST connectors, and we'll have to make up some cables and get started that way. Okay, I'm going to start familiarizing myself with the Nordic Semiconductor nPM1300 evaluation kit, which is this card here, and this is the associated fuel gauge board connected right here. I've plugged in this USB-C connector to the computer, which is going to be running the NRF Connect for desktop and the nPM power-up circuitry or software. This USB-C connector is connected to my power supply, which is set for 5 volts and 250 milliamps, because this battery probably can't take more than about 250 milliamps for charging. So what I'm going to do is just switch over to the software so we can see how that is set up. And then I'll plug in the battery and we'll see how that works. Desktop that I've just started up, and when I first started this, it asked me to update this quick start software here, and so I clicked on that and it went through a little update which was monitored, and then I had to install the nPM power-up software, which was just showing an install button over on the right here, and I also installed the power profiler just in case I need that. But once I had clicked on install for these things, they installed, and now they're available for running. So I'm going to open up this nPM power-up software. So that's what it looks like when it starts up, and I'm going to expand it a bit. So here we have the dashboard, which is showing you the battery status and some charger status and so on. And I'm going to plug in the battery and just see what that looks like. So if I plug in the battery here, and I can enable the fuel gauge. Oh, first of all, I have to select the device that I'm going to be messing around with. So that is here. This is the nPM 1300 evaluation kit. So I'll select that. And now it's actually looking at the, oh, it's doing some installation on my computer. There we go. And it's already saying that this battery is sitting at 47.6%. The voltage is 3.72 volts. I don't have a temperature sensor on it, so it's sitting at minus 88. The charger is not enabled, and it's setting it at 3.6 volts and 32 milliamps. So this battery, I want to set this up to 4.2 volts. So I'll do that, 4.2. That's its nominal maximum. Whoa. And I'm just going to set it up to 200 milliamps charging current, even though it can probably take 250 milliamps. Now I need to turn on the power supply, which is over here. So that's the USB power supply for charging, and it's now sitting at 5 volts, and it is current limited at 250 milliamps. So now if I hit this enable, this says here it's 47% charged and the time to empty is 26 hours. So if I hit enable on this charging panel, it doesn't do anything. So what happened there? Let's go into the charger details on this tab up here, and we can look down and see some details here. Okay, so it looks like it's expecting a thermistor, and if we go in here and say ignore the thermistor, that should prevent this thermistor from preventing charging. So let's go back to the dashboard and enable this thing again. Now it says, okay, time to full, so it's charging. If we read yeah, so the voltage is going up. You can see it's 3.83 volts, and this percentage is going up. We're charging it at 200 milliamps, and I'm reading on my power supply 0.211 amps. So that's pretty accurate enough for what I need. So it's up to 3.84, 48.1%. So that's how it works, I guess. I'm just sort of learning as we go here. Eventually, I want to use this setup to do a full charge-discharge cycle to see the capacity of these batteries that I have. This particular battery is pretty old, and it's still sitting at 48% charged, but it's been sitting around for years. So once I figure out how to do some more full charging cycles, I'll resume this video. But it's going up here, 48.8% now, and the voltage has gone up to 3.86 volts. So it's got a ways to go before it gets to 4.2, but once it gets there, I'll be able to run a discharge cycle and see what happens in terms of the time it lasts. Anyway, all looking good so far. This software is easy to use. It's fairly intuitive. Even just, updating software is just a single click. There's no messing around with trying to figure out where the software is located and all that stuff. It's just plug and play.